All right, so in these examples, I'm going to do two examples. We're going to look at how we can use our properties of equivalency to undo and do algebraic equations. So how to solve them and then how to kind of work backwards and use backwards thinking. So in this example, we start off with our solution, x equals 5, and then they give us some things that we're going to do, and then I'm going to show you how we can work backwards to get our original, which would end up being our solution, back. So the first thing that it says to do is multiply both sides by 4. So we have our equation x equals 5. So if we were to multiply both sides of our equation by 4, right, that would be our multiplication property of equivalency. Then we would end up with 4x is equal to 20. Okay, 5 times 4 is 20. Then they want us to subtract 2x from both sides. So we would minus 2x from both sides, minus 2x. So it doesn't matter. Order matters with subtraction. So you have to make sure you're doing 4x minus 2x, not 2x minus 4x, because you'll get two different answers. So now on the left-hand side, we have 4x minus 2x, which are like terms, so we can combine them, right? 4x minus 2x is 2x, is equal to 20 minus 2x. So we can't combine 20 and 2x. 20 is a constant, 2x is a variable term, so we just rewrite it. Our third step is to multiply both sides by 2. So we want to multiply the whole left-hand side and the whole right-hand side by 2. Okay, so 2 times 2x is 4x. And then on the right-hand side, we can use our distributive property. So we'd have 2 times 20, which is 40, minus 2 times 2x, which is 4x again. And then last step, we would subtract x from both sides. So we would just do minus x from both sides. And so 4x minus x is 3x. And on the right-hand side, we can combine the minus 4x minus x. So we'd have 40 and minus 4x, which we can think about as plus negative 4x, right? So plus, and we have negative 4x minus x. So we start at negative 4 and we go to the left, one more x, we'd end up at negative 5x. And then anytime you see plus a negative number, you can think of that as just subtraction. So we can just change that to a minus sign. So now we have an equation that we would normally start with, right? We have 3x is equal to 40 minus 5x. And normally we'd be asked to solve for x, and we'd get x equals 5. Well, how do we get x equals 5? Well, we'd have to work backwards. So we want to look at all of the operations that we did on the left-hand side, and we would want to undo them by using our inverse operations. So let's say now that we have this equation, 3x is equal to 40 minus 5x. Well, the first thing we want to do, we want to start all the way at the end, and we want to work backwards, right? So the first thing we want to undo is subtracting x from both sides. So instead of doing that, let's instead add x to both sides. So when add x, we want to add x, right? And we can just add that x over here. So 3x plus x is going to give us 4x, right? And that's equal to, and we can only combine our variable terms. So negative 5x plus x will give us negative 4. So 40 minus 4x, right? And that's what we got here. So now we want to undo multiplying both sides by 2. So in order to do that, we have to divide both sides by 2. And we have to divide the entire left-hand side and the entire right-hand side by 2, not just part of it this time. So 4 over 2 would give us 2. So on our left-hand side, we have 2x. And that's equal to, well, we can think of this as kind of two separate parts. We have 40 over 2, which is 40 divided by 2, which is 20. And then negative 4x divided by 2, which is negative 2x. Okay, so that's what we had here. Then we need to undo subtracting 2x from both sides. So instead of subtracting 2x from both sides, we want to add 2x to both sides, right? So now we have 2x plus 2x will give us 4x. Then we have our 20, and then negative 2x plus x will just give us 0. Okay, that cancels out completely. A negative 2 plus 2 gives you 0. So we could write plus 0, but we really don't have to. Anytime you add plus 0, it doesn't change the value. So now we have our 4x is equal to 20. And the last thing that we have to undo is we have to undo multiplying both sides by 4. So instead, we're going to divide both sides by 4. We have to divide the entire left-hand side and the right-hand side. So 4 x over 4, well, 4 over 4 is 1, right? So we just end up with 1x. But we usually don't write that 1 in front anytime you have 1 as a coefficient in front of an x, we can just say x, right? We don't need to know it's 1x, you're just writing an x. If it's more than that, then you write the number in front, but you don't have to write it for 1, and normally we don't. And then 20 divided by 4 is 5. Well, look at that, right? We ended up with the solution that we started off with in our table. All right, let's do one more example. So here again, we're starting with our original equation, which will end up being our solution of x is equal to negative 8 this time. So the first thing they want us to do is multiply both sides of our equation by 3. So multiply the left-hand side by 3 and the right-hand side by 3. We'll end up with 3x is equal to negative 8 times positive 3 is going to be negative 24. Negative 24. Negative times a positive is a negative. Okay, anytime the signs are different when you're multiplying or dividing, you always end up with a negative. If the signs are the same, you end up with a positive. All right, then we want to subtract 9 from both sides. So we want to subtract 9. So we have, let me write that the same way I did before. So minus 9, minus 9. So we have 3x minus 9 on our left-hand side. We can't combine those. 3x is a variable term and 9 is a constant, so you just write it the way that it is. And then on our right-hand side, we have negative 24 minus 9. So if you imagine negative 24 on a number line and we're going minus 9, which means we're going to the left, we're getting more negative. Okay, so negative 24 minus 9 will give us negative 33. And then we want to divide both sides by 3. So the entire left-hand side, the entire right-hand side divided by 3. Well, what does that look like? So we have, again, we can think of this in kind of two parts, right? 3x over 3, well, that'll become 1x, which we just write as x. We have negative 9 over 3, positive 3, which will give us negative 3. A negative 9 over divided by positive 3 will give us a negative number. And then negative 33 divided by positive 3 will give us negative 11. So now we have x minus 3 is equal to negative 11. And then we want to add 6 to both sides. So plus 6 plus 6. And of course, on your papers, you'll have more room. I'm just trying to fit it in this little box here. So now we have x minus 3 plus 6. Well, minus 3 and plus 6 are both constants, so we can combine them, right? And again, if you wanted to think of this as plus negative 3, right? And then you could just say, well, negative 3 plus 6. If I imagine negative 3 on my number line and I'm going to the right 6, where would I end up, right? Well, we would end up at positive 3, right? You go 3 to get to 0, and then another 3 to the right of 0 to get to positive 3. So we go a total of 6, right? 3 and 3. So we'd have x plus 3 on our left-hand side. And then you can just use a calculator if you want to for your negative numbers, or you can just try to imagine your number line. If you start at negative 11 on your number line and you go to the right 6, you end up at negative 5. Okay, so now again, we are ending with the equation that we would normally start with, and we need to work backwards. We need to do our inverse operation. So in order to undo adding 6 to both sides, the first thing we want to undo or do is to subtract 6 from both sides. So minus 6, minus 6. So we have x is equal to positive 3 minus 6 will give us negative 3. And negative 5 minus 6 will give us negative 11. And then we want to undo dividing both sides by 3. So we're going to multiply both sides by 3, just like this, right? So now we can use our distributive property. That's going to give us 3x minus 9 is equal to negative 33. And then we want to undo subtracting 9 from both sides. So we're going to add 9 to both sides and only to the like terms, right? So this creates a 0 pair. Negative 9 plus 9 gives us 0. So we don't have to include that. So we just have 3x on our left-hand side. And then on our right-hand side, we will get negative 33 plus 9, which gives us negative 24. So 3x is equal to negative 24. And the last thing that we need to undo is multiplying both sides by 3. So we're going to divide our entire left and right-hand side by 3. Any number over itself is 1, so that creates a 1 pair. So we're just left with x. And on the left-hand side, we are left with a negative over a positive. The signs are different, so we're going to end up with a negative 8, which is what we started with as our solution. So hopefully that helps you solve multi-step equations. There's going to be some combining like terms, right? Like we did here and here. There's going to be some distributive property that you're going to need to use. And yeah.